All right, today we are going to spend a second day on 13.8. So you have the notes in front of you. So let's review SOHCAHTOA and the three reciprocal trig functions. So go ahead on your papers and draw a right triangle. Across from theta we call the opposite side. Beside it is the adjacent, and the hypotenuse is always across from the right angle. So for sine theta, SO stands for opposite over hypotenuse. What we learned last class is that its reciprocal is cosecant. So the reciprocal becomes hypotenuse over opposite. Cosine theta, CAH, is adjacent over hypotenuse. Its reciprocal is secant theta, so that's hypotenuse over adjacent. And then the third pair begins with tangent theta. TOA is your opposite over adjacent, and its reciprocal is cotangent, so that's adjacent over opposite. So this is what we learned previously. So we're going to apply this to some right triangle trigonometry. So in example 1, it says find all 6 trigonometric ratios of theta. So let's draw the following triangle. I'm given 2 sides of the triangle. So across from theta is 6, and adjacent to it is 9. So how do we find the missing side? Well, we have something in our tool belt called the Pythagorean theorem. So let's pull out that tool, and we would take 6 squared plus 9 squared equals c squared. Well, that's 36 plus 81, so c squared is 117, so c is 117. Go ahead and label your triangle then with that hypotenuse, square root 117. Then we're just going to go through and do our pairs. Sine theta, SOHCAHTOA is opposite over the square root of 117. And we're not going to worry today about rationalizing. And then cosecant is just the reciprocal, so it's the square root of 117 over 6. Cosine theta would be adjacent over hypotenuse. So that's 9 over radical 117. The reciprocal is secant theta. So that's radical 117 over 9. And then the last pair is tangent theta, which is 6 over 9. Well, we never ever leave a fraction that isn't reduced. 3 goes into both of those. And then take your reduced answer and flip it. So cotangent theta is 3 over 2. So if you have a right triangle and you know 2 of the 3 sides, use Pythagorean theorem to find the missing side. Then you're going to go through, use SOHCAHTOA, find sine, cosine, tangent, and then just flip each of those. All right, example 2. All right, if you're feeling confident, copy the triangle down and pause the video and try to find the missing side with Pythagorean theorem. If you're very confident, go through and find all 6 trig ratios of theta. I will go ahead and use Pythagorean theorem and do a squared plus 5 squared equals 7 squared. A squared plus 25 equals 49. A squared is 24, So A is the square root of 24. Now the square root of 24 can be simplified. That's 4 times 6. So make sure your radicals are simplified. You do not leave any perfect square factors in there. If you prefer the little factor tree, do 2 times 12, 2 times 6, and you'll still get a pair of 2's that come out as 2 square root 6. Alright, so here we go. Sine theta. So look where theta is, and that's where your opposite and adjacent will be. So from theta, the opposite is 2 radical 6 over 7. Cosecant theta is 7 over 2 radical 6. Cosine theta is adjacent over hypotenuse, so that's 5 over 7. Secant theta would be the reciprocal, 7 over 5. If I'm going too quickly for you, please pause the video, write down what you need, and then press play. Tangent theta is TOA. TOA would be opposite over adjacent, so that's 2 radical 6 over 5. Then cotangent theta is 5 over 2 radical 6. Again, if you have a right triangle and you know 2 of your 3 sides, use Pythagorean theorem to find the missing side, then use your SOHCAHTOA to get your 6 trig ratios. Go ahead and write down the following triangles. Now theta is up in the top, and that's okay. And I have 2 sides of 3. Please pause the video on this one. Find the missing side using Pythagorean theorem. Remember to simplify your radical. And then try to do all 6 by yourself. Okay, please pause the video. Alright, this is 3 squared plus 3 squared equals c squared. 9 plus 9, that's 18. C is the square root of 18. This one, I'll do the factor tree method. So a pair of 3's comes out, and it's 3 radical 2. So here we go. Sine theta. Now theta's up in the top corner, so my opposite is directly below that. So it's 3 over 3 radical 2. The 3's cancel. Okay, my 3's can cancel, and I'm left with 1 over radical 2. So cosecant theta is radical 2 over 1, but radical 2 over 1 is simply radical 2. Cosine theta is adjacent over hypotenuse, so that's 1 over radical 2. Secant theta would be the reciprocal, which is radical 2 over 1. Tangent theta is opposite over adjacent, so that's 1. Cotangent is the reciprocal of 1, which is 1. Make sure you are memorizing SOHCAHTOA and the 3 reciprocals, that cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, cotangent is adjacent over opposite. Alright, now I'm going to do 2 examples that review what we did last class. Find the exact value of secant negative pi over 6. So here we go. Find out what angle measure is negative pi over 6. You should have memorized pi over 6 is 30 degrees, pi over 4 is 45 degrees, and pi over 3 is 60. You need to memorize those 3. Pi over 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. So if I have negative pi over 6, that's negative 30 degrees. A negative angle is a clockwise rotation. So negative 30 just rotates into the fourth quadrant 30 degrees. So step 1, find your angle measure in degrees. Step 2, sketch it. Then the angle measure from the x-axis to that is the angle inside your triangle. It's either going to be a 30, 60, 45, 45, or it's on the unit circle. So in this case, it's on the circle across, or I'm sorry, it's in a triangle. Cross from 30 is 1, cross from 60 is radical 3, the hypotenuse is 2. You do need to put your plus or minus signs. This 1 is going down. Secant is the reciprocal of cosine. If cosine is adjacent over hypotenuse, this is going to be hypotenuse over adjacent. So let's look at my triangle from 30 degrees. The hypotenuse is 2. The adjacent is radical 3. We can rationalize this by multiplying by radical 3 over 3. So it's 2 radical 3 over 3. All right, cosecant, 2 pi over 3. I'm going to go ahead and erase this. We're supposed to know those. 2 pi over 3. I have 2 sets of 60 degrees, so that's 120. 120 is in the second quadrant. How far away from the x-axis is 120? It's 60 degrees. So across from 30 is 1. The hypotenuse is 2. Across from 60 is radical 3. Well, I'm moving left, so that's a negative 1. Cosecant is the reciprocal of sine. So I now need hypotenuse over opposite. So this is 2 over radical 3. Well, we just rationalized that in the last problem, so why reinvent the wheel? Why do the work again? That's 2 radical 3 over 3. All right, letter B, or excuse me, C. 5 pi over 3 is 5 sets of 60, so that's 300 degrees. Well, 300 degrees is in the fourth quadrant, and that is 60 degrees away. Across from 30 is 1, the hypotenuse is 2, and across from 60 is radical 3. Thinking about my positives and negatives, the radical 3 is negative. Cotangent is the reciprocal of tangent, so for cotangent, I need adjacent over opposite. So adjacent is 1, the opposite is negative radical 3. I can multiply by radical 3 over 3, put your negative up in the top. That's negative radical 3 over 3. All right, now take out your calculators. If you don't have yours with you, pause the video and grab a calculator. I put all 3 of these in degrees, so check your mode. On the red calculator, make sure it says degree. You press the button to the right of the second. It says DRG. DRG stands for degrees, radians, and gradients. Make sure you shift it so that it says degree. On the graphing calculator, go to your home screen, go down to settings, document settings. Make sure angle says degree. If it doesn't, change it to degree and go to the bottom and click Make as Default. On the graphing calculator, if you press your trig button, press the trig button, you have cotangent. If you're using a red OGT calculator, you've got to type in 1 divided by tangent negative 34 degrees. You should be getting negative 1.483. Try letter B, cosecant 26 degrees. Now you should be in the correct mode. On the red calculators, cosecant is 1 divided by sine. Letter C, secant is 1 over cosine. All right, last problem. It says you can use a reciprocal trigonometric function to solve a real-world problem. It says a restaurant is near the top of a tower. A diner looks down at an object along a line of sight that makes an angle of theta with the tower. So you can see to the right where theta is. It's up here in the top right. The distance in feet of an object from the observer is modeled by the function d equals 601 secant theta. It says how far away are objects sighted at angles of 40 degrees and 70 degrees. So we're going to do this twice. You're going to do d equals 601 secant 40 degrees, and you're going to do d equals 601 secant 70 degrees. You're going to find those two distances and then subtract them. You should be in degree mode back from example 5. So go ahead and figure out how to do this. On the red calculator, here's how I would suggest you try to type this in. Do 1 divided by cosine 40 degrees, press enter, then multiply by 601. Let me repeat that. I would suggest on the red calculators, do 1 divided by cosine 40, hit enter, times 601. The graphing calculator, you guys can just enter this straight across. 601, go to trig secant 40. Yours will be a little bit easier. So my first distance is 784.5. My second distance is 1757.2. So how far away are objects sighted at those two angle measures? Well, you take 1757.2 minus 784.5. And I got 972.7, and that's in feet. All right, that concludes the notes, and you will receive the homework shortly.